In this video, I would like to go over what we have so far, and then I will show you how we can add the reflectivity and the bump mapping to it. So far, we have a diffused material, and this diffused material is basically giving color to our object. So we use a wave texture to create the rings, and we use a Voronoi texture to create the pores. And you can also see the wave and the Voronoi texture are also colored and then mixed together, so that, for example, the wave texture gets a little bit more of a visual material. So it's a little bit more interesting. Okay. So this basically is a very basic approach to how to create the color for a wood texture. In another video, I will actually go more into detail how we can then generate specific wood types and also specific veneer types. But in this video now, I would like to cover how we can create the glossy and the bump mapping for it. So let's actually take a look at the end of our material. So there we have the diffuse node. The diffuse node basically is just a material node we can use to create a matte surface. So it has no reflectivity. And in computer graphics, when we want to have something being reflective, that's for example the glossiness or the specular. So we need to add a shader or a building block that adds reflectivity to our object. So Shift A, shader, and then we can add glossy. And for example, put it to here. So we zoom in, you see there's a little similarity between diffuse and glossy. So both, for example, have a color, both have a roughness, and both have a normal. But the roughness, for example, in the diffuse does more affect the look of the diffuse. So maybe how rough the surface is. And you see the light interacts a little bit different with it. Now the roughness for glossy, that actually truly defines how rough or how clear or smooth the surface is. So when the surface is very smooth, that means the reflection is clear. If the surface is being rough, then, when the glossy shader is set to rough, then that means that the surface is also rough. Think about an iMac and you sandblast the aluminum, the reflection isn't clean. So to see reflections, we need to see, or we need to have something in the reflection. So give me 1 second. I will add an object to it. So for example, a small cylinder there. Perfect. Let's put it to there and there. And I will make this one red so it stands out nicely. Okay, good. And let's do a rendering. So there now you can see we have a glossy material. So my whole object is grayish because it reflects this white environment. And then there we see where we have the red object in front of us. We see the reflection in it. Now we play with the roughness. You can see how the reflection gets increasingly blurry. And that gives you the feel that maybe the surface got sandblasted. So the problem with computer graphics is simply we use a simplification of real life. So instead of trying to create a geometry where the surface really is sandblasted, we simply try to adjust a material or shader block so it gives us the illusion of what we desire. So in our case, a blurry reflection because the surface is roughed up. Okay. But now, how do we mix these two things together? Because you can see I can only add one material node into the material output. And there we need to add another shader and then a shader mixer. And then we can combine these two together. So now we use the diffuse color and the glossy, and we mix them together. And then here we have a slider to, for example, say how much should, for example, the diffuse be mixed with the glossy. So with the factor of 1, again, shader 2 will be used 100%, so everything is glossy reflective. It's more like chrome. And if we put this over, then this is maybe more like raw cut wood. There's no reflectivity on it, which tells the viewer that we didn't put, for example, any polyurethane over it. And when we say, well, maybe a little bit, the problem you can see that, well, it adds actually this shininess all over the object, and that's actually not very realistic. So how do we know, for example, make the reflection look more realistic? And again, there's more to it. So step by step, I will introduce all the different building blocks. But at the beginning, what you need to understand is if, for example, we look perpendicular onto a surface, or if we look tangent to a surface, the reflectivity will change. And that is something Mr. Fresnel discovered. And that's the reason why when we go to Shift-A input, there is a Fresnel node. Now this Fresnel node, index of reflection, for the moment we can keep it as it is. This is basically the node in computer graphics you will come across most of the time when we need to have a reflective material that, based on the view angle, adjusts its strength. So essentially what I want is, when I look perpendicular onto the wood, I don't only want to see a lot of reflection, and when I look tangent to the wood, I want to see more reflection. And essentially, to again create this type of an illusion, I want to be able to mix between diffuse and glossy, and on the geometry and how it's positioned in 3D space and how it looks towards the camera, I want this factor to be adjusted, but not uniformly. I want it to be angle-wise adjusted. And that is the reason why when we now plug the Fresnel node into the factor, you see that the end grain has nearly no reflection. And if I go to here, you see this is highly reflective. But if I rotate my view to there, you see now there's just a little bit of a reflection. Also, when I rotate my view, you see the end grain gets increasingly more reflective, or the opposite. And then also here, maybe 0.1. This gives it a little bit of shininess. 0.01. So the reflection is there. Feels clear, but is a little bit blurry. 0.5, that's way too much. 0.05. Okay, good. Okay, so this is the basic principle how we mix different shaders, because again we try to achieve illusions. Now in real life we take the wood and then we put the polyurethane on top, which is why, for example, we have the diffuse, and then we mix this with a glossy. For example, we could say, well, the wood is on the bottom and the glossy is on top. However, the way how the node system works is diffuse is number 1, because you see this is actually shader 1 and shader 2. So shader 1 is being mixed with shader 2, and then we define how it is being mixed. So while in real life we actually put polyurethane on top, in computer graphics we rather not put it on top, but we replace something with it. So when I say replace, so let's say we go to here. Now the front area we see mainly the diffuse, and on top there we are replacing the diffuse by mixing, or not mixing, but making glossy more visible and diffuse less visible by the Fresnel node. And then that to a viewer will give you the illusion of that there is some sort of a reflective coating on top. Okay, so if I, for example, also select this red object, and for example put the glossy to here, then let's add the mixer, and then I have to shade this one smooth. You see also there the reflection is nice and clean, and also there we have the ability to mix linearly, which is not what I want. There's another nice thing to show you when we use the Fresnel node now. You see actually at the round object that at the corners, or the edges, sorry, the reflection gets stronger, and at the center the reflection gets weaker. This can actually be nicely observed when we turn the color off. So this is also one good trick when you want to observe just how a reflection, for example, works. Disconnect, for example, the diffuse input to the mix shader. So basically the diffuse is combined with nothing, and then we can see the reflection nicely. And there you see, because of the Fresnel definition, which says perpendicular is less and tangent is more visibility, here in this area the reflection is less mixed in, and on the corners, because the surfaces become more tangent to the camera, the reflection will be stronger. For example, when you create any vessel, Coke bottle, or anything where we have a coating on top, this is the way how it should look like. If it looks like this, then it's more like metal. Okay, so this is basically a universal principle that can be applied literally to every material. So before we continue with the reflectivity material, I would like to talk about now the three-dimensional structure. Because if we rotate the camera to this view, we can see color-wise that we're talking about wood, but because the reflectivity is so perfectly uniform on top of the face, it gives us the feeling that this is just a print. So it's maybe plastic, it's not really wood. And certain materials, for example, like wood or fabric, they're not flat, like glass or metal. They actually have a three-dimensional structure. Specifically, fabric materials or jeans, it's not really a surface, it's more a volume. So the problem is we can't really model that because it's too complicated and dense. So we need to figure out how could we create a faux impression of a three-dimensional structure on top. And I would like to introduce you now to what's called bump mapping. So to do bump mapping, we can do the following. So inside the node editor, Shift A, and then we go to vector, and there we have bump. This one you can use. And let's take a look at it for the moment. So we have a strength, we have a distance, we have a height, and we have a normal. Okay. And this, for example, we can plug into the normal. So the bump mapping output goes into the diffuse or the glossy normal. And then into the height, for example, we can put in this one from the color ramp. And if you now take a look at the screen, the rendering on top, you can see that something happened. Let's remove this and let's add this again. Okay, so what's going on there? Maybe let's go to this view, and then the strength we can lower maybe to 0.1 or maybe 0.2. There we see that something is happening on the surface. So maybe let's add this to the diffuse, and now I would like to only see the diffuse result. I could drag this one over. There's actually a really great ability in cycles. We can duplicate this material output, and then you see when we click these outputs, it switches, well, between different versions of my material. So I could now say, well, only show me the diffuse output of, or only show me the end result of what comes out of this diffuse material. And there you see I can show with and without. So I don't have to reconnect the nodes here all the time. That's a very nice shortcut. Okay, so let's maybe zoom out a little bit. Let's set this to 0, maybe set this to 1, and there we see as well something is happening, kind of like these gray dots, etc. So basically what the bump mapping is doing, we use actually here this color ramp. So here's another way to also better take a look at how the color ramp later actually will look like. This is the color ramp. So this black and white image is being used for the bump mapping to define where surface should be pushed in or risen, and where, for example, the surface should not be touched. And now when we switch between the diffuse with the bump, or for example just the color ramp, you can see everything that's white does something to the texture, and everything that is black does currently here nothing to the texture. And for example, if I do, for example, this, so this is now a view of the Voronoi texture without the bump, without the color ramp, and we drag this one into the height. Well, let's take a look, and there you can see now that if we zoom in a little bit more, there's a lot more going on. If I set this to 1, you see the whole surface seems to be affected by this bump effect. So, and this is maybe at the beginning a little bit tricky for new users to understand, but essentially when we mix, for example, with a color mixer, we have a value of 1 and a value of 2. You can also think about, well, this is 0 and then we have 100 steps, or this is 0% and 100%, or this is left and this is right, black and white. So essentially here with black and white we have 1 and 2. Here we have 0 and 1, or 0 and 1 if you want to see it this way. And with a number we have all the steps in between, so from 0 to 10% to 33% to 88 to 91 to 100%. And the same essentially we have with those textures we create. So white is one side, so let's say 0, and black is the other side, let's say 1. And then the gray values from 0 to black are actually all the different steps here in the factor from 0 to 1, or 0 to 100%, if you want to see it this way. Because essentially we see a grayscale value, but the software simply sees a number. Another way to explain this, you see here we have the slider. Let's go to HSV. So here is the value, and you see the value is actually a number. And for example, like 0.5. So a medium gray is 0.5. Okay, so that is the reason why, for example, when we use the complete untouched Voronoi texture, the bump mapping affects the whole area. Because here we have blacks and whites, and then all the gray values in between. For example, here in this case, here we have actually with color ramp adjusted the texture, so we basically have more black areas, and then we have the pores as white streaks. And if we plug this one now into the bump mapping, and that's the reason why now in this area we have something that's happening. And the bump mapping, basically based on the black, gray or white color you get, creates artificial shadows and highlights on a surface, which then in return gives you the illusion of actually artificial grooves or scratches on the surface, because where we have a scratch, there we have a shadow. So this is a pure two-dimensional fake approach. So this is actually not really real. From a distance this can look fine, but when we, for example, zoom in more, there you can see that actually here we have these shadows, but they're actually all perfectly flat. It's fake. But here's also one thing. You notice this bump mapping effect is very difficult to judge. So if you want to see a shadow or something like this, you can't be in an environment that illuminates everything perfectly. So let's turn actually the background light off, and then we will add an area light. And maybe this area light I move to the left. Let's make this nice and big. Let's rotate it. Let's move it up. And let's take a look. And you see there are the bumps. So, and currently you can, for example, see the way how the bump mapping here works. We have a highlight on the left, and we have a highlight on, a shadow on the right. So when we have first highlight and then the shadow, that gives us always the feeling of something is risen. So this is not a groove or a scratch. So the direction of the bump mapping is actually wrong. So what we can do now, we have to invert it. Well, there is actually the invert node for it. Where was it again? There. Color, invert. And now you see the direction of where you have a shadow and where you have a highlight is switched. So this now gives you the feeling of a groove. This is a hill on top and a groove. If we set this to 0.5, there's nothing. Okay, so let's, for example, move actually this light a little bit more to the right. So we shine light onto the end grain. And also there you see the pores much better. So from a distance, this really actually looks like there are wood pores in it. There are actual holes because we see all the shadows and then the highlights. But again, if we really zoom in, and let's say here we go to this edge. So this line is a giveaway that this is simply a fake, because this actually would have to be carved down if this really would be a groove. So this means actually this effect works really great when you're further away. It renders also very fast, but it is not really the most realistic approach. But in terms of render speed, it is very good. And as long as you're that far away, you won't really have any problem that, for example, you show that the three-dimensional surface structure you try to generate via the bump mapping is actually fake. So we can now play with the bump mapping. We can make it very aggressive. We can also, for example, make it very light. So there is just a little bit something going on. So maybe just some pores or so, some scratches. And to find the correct values, beginning of this video session, I mentioned in one video we will cover more how to recreate more realistically certain wood types and then match it. To do that, basically, or what I wanted to say is there are no specific values I can tell you have to use. You need to visually match your rendering to your wood sample. And again, during class, I said it's really important that you try to collect actual objects as material samples, because nothing is more complicated than trying to make a material look good when you have no reference. When you have an actual real-life reference, then it's very easy to adjust material settings so that the material you virtually create is more realistic. Okay, good. So for the moment, let's leave the bump mapping where it is, and I would like to show you now what happens when we go back to the material output that also has the reflectivity added. So I need to rotate my view because you see there's no reflectivity. There actually is, because there is a black environment and this whole area is reflecting the black. But if I rotate my view, then there I can actually see also the light being reflected on it. So you see, the bump mapping does not only work on the diffuse, but we can also use the bump mapping for structuring the reflectivity really nicely. And you can work with both together. For example, without the diffuse, they are just inside, but only inside where you see a reflection, the grooves visible. And when we mix this together with a diffuse that has actually the bump mapping applied as well, then we also see kind of like the shadowing of these grooves inside the bump image. Yeah, for example, here, see, something seems off, like why do we have these lines? No, this actually feels more like somebody took a white pencil and put some lines on it. But if we give this also to the diffuse, then you see, hey, there are like shadows and highlights, and there are the reflections. Okay, so this is actually here another good view, because this and then we bring this whole bump mapping to an end, gives you another piece of insight to what actually the bump mapping does. So with the diffuse, I mentioned that it kind of like creates artificial shadows and highlights, but you noticed you need actually a light that shines light onto the object to also make these shadows to really pop out. And in the same way, because now we apply actually this bump mapping also to the reflectivity, so to the glossy, it shows actually stronger reflections where the bumps are. Now what's happening is you can see here we have a little bit of shininess and the surface is very flat. And then with the bump mapping, right actually where we have those pores, it actually adjusts the surface normal, so that actually where these pores are, the material, let's say material surface normal is rotated because it's pushed in, and then that surface normal, because it's not flat anymore as the wood top, is actually at an angle and will see the light more. And that's the reason why then inside these grooves we see actually those reflections. But again, this is all completely fake. But you see it renders pretty nice and fast. And you see you can actually work with 0.05. You see there we see a little bit of bump mapping already. You don't really need to go very high. This is too aggressive. 0.1, 0.05. You have to see what will work good. Okay, so let's bring this slowly to an end. So the bump mapping currently only uses the pores. It does not actually use the diffuse material from the wood rings. So when we zoom out a little bit, and I will clean up those, and maybe put this one to there. You can see that I use the color ramp from the Veroni, and that is being fed into the bump map. But actually I would like to make use of my wood rings as well. Now wood has basically two types of materials. You see it color-wise, but it also means one area is softer, one area is harder. And that, for example, also can have an impact on the bump mapping of the wood surface. You noticed in class when I handed around the freshly cut hardwood piece that even without being sanded, just perfectly cut on the machine, you can actually feel the rings. There was a slight bumpiness to it. So instead of just only using the Veroni texture to create the pores and the bump mapping, we also should use, for example, the wave texture. So how do we do this? Well, we can, for example, adjust our design here a little bit. I move this a tick closer, and there. Actually, I will take all this and move it a little bit out. So it's, for example, based on how we group them around, visually we can, for example, already declutter everything we see, so it's a little bit easier to understand what we are doing. These are actually still very simple nodes. I can show you other materials which really look like a nightmare. And we need a little bit of information from this wave texture, and then that will go into the bump mapping. Now again, for bump mapping we want black and white, so we do not want this color stuff. So what I will do is first I will just create myself a new color ramp, maybe put this one over, and then this one I will adjust back the visibility there, okay, perfect. And then the factor I will move into here, and I can take a look at maybe how does this look. Why is this actually this way? There. Oh, never mind, sorry. The wave texture is already black and white. Good. So I didn't need to clamp it. Okay. So one easy way is now this I would like to mix together with what comes out of this. So we can do this easily with another color mixer. So color mixer, and then here, let's say this goes into the bump mapping. So U and U mixed together go into the invert. I think I have to see. So this is actually now the look of, for example, the wood grain, and this is, for example, now the look of the pores. There you can see a distinct difference. 0.5, nicely mixed. Maybe for the moment let's increase this a little bit so we can see the effect somewhat better. Only pores, only the wood grain. And then we have to figure out how much from each do we want to include. And even there again, it can be difficult to figure out what actually we're doing. So we can include, for example, a small preview node, so we have a little better way of seeing this stuff. Let me see the factor or this one. Okay. And whoops, that I didn't want to. Shift A, and let's add a color ramp. I will add this one back to here, because now with the color ramp I can, for example, clamp, as you can see, this grayscale texture. So why is, for example, this useful? Well, I will put this one to there, and then I only want to see this. Okay. And I will remove the material, so I only see, for example, the bump mapping effect. Okay. So if I adjust this, you can see, for example, what type of bump mapping I have there right now. So you see this, or if we go this way, you see I have more of those rings. Okay. 0.5. Now we put in now the pores in addition. Maybe something like this. Then here I will bring this one back in. Okay, and let's take a look everything together with the pores. 0.1. Yeah. So this actually, as you can see, then starts to look a little bit better. So to summarize this, also here we can use the wood, so the wave, and the pore texture. We give them different colors, and then we can mix them together to colorize our diffuse material. So it has a little bit more of visual quality. But then when we want to create the textures for the bump mapping, we can, and you want, so texture-wise everything matches, we can reuse what we created here for our wave and the Voronoi texture. And with the Voronoi texture we only want to have few pores, so we use, for example, here color ramp, which we nicely clamp with a transparency element. That, for example, is being used in there for the color mixer. And we also clamp, for example, with a color ramp, the wood texture, so we can define where we want more a bump mapping that, for example, pushes in. Now currently the whole thing is very bumpy, and this is not really what I want, and I want more flat surfaces, and then in some areas it actually should be, for example, pushed in. So let's say maybe something like this. And when you walk around and you see somewhere wooden doors where there's a nice wood veneer on it, go next to it and try to look across it so you can see on a wood surface what seems not to be pushed in and which areas seem to be pushed in. And that's basically what we try to achieve here. And on these two different color maps, then we can mix together as well and then define how much, for example, of the wood and the pore texture do we see and how do we maybe mix them together. We can also, I think talked about this before a lot, we can mix them, we can add them, we can multiply them. There is an overlay function, so there are a lot of different color operations you can even use to customize, for example, the different looks. So you do not only have to use mixer. With mixer it's more like making both transparent and then mix them together. But with the overlay you see we have actually the pores and the wood nicely put together. Or for example with the add, you see there's a difference between the add and the overlay, specifically here in the black area. And that actually makes more use of the pores. Okay, and that's really up to you to play with it. Those are your creative abilities to adjust then this texture. And you see then this texture, this is basically a black and white, and again one pure white stands for one value, let's say 0, and pure black stands for the opposite spectrum value, let's say 1, and then all the grayscale values in between are basically like here with a factor from 0 to 1. And that basically then tells, when we put this into the bump node, where on this object, based on the color of this texture, should I create a bump or not, or leave the surface. And then here with the invert we can actually switch the direction, and then the bump mapping is being put into diffuse and glossy, into the normal, and then this is what we will see. So, and then in the next video we will actually take an actual wood sample and try to accurately recreate it. Because something that we didn't do yet so far is to think about scale and size, and you will actually be surprised how some wood materials are very dense, so the rings are very compact, and other materials, specifically softer wood, they have not that dense of a ring structure. So based on the type of wood, we not only have to adjust the colors, but also, for example, the size of the rings. And the easiest way there is always when we have an actual woods example, and then we can cut it, look at it, maybe scan it, and then recreate a three-dimensional object that matches the dimensions. And then we can try to match our virtual material to the scanned object. And then that's basically the easiest way to make sure you get a wood material that matches.